Okay, so let's talk about factorizing. Before we do that though, let's just backtrack and talk about what a factor is. Because obviously in the word factorizing is the word factor. So if we think of the number 20, a factor of 20 is another number that will fit into 20 exactly. So 1 is a factor of 20 because that fits in exactly. 2 is a factor, 4, 5, 10, and 20. All of these numbers around the outside, they all fit into 20 exactly, so they're factors of 20. So just like we can find out or identify factors of a number, we can also find out factors of an expression. And we do that by comparing the terms that make up that expression. So in this case, we have two terms in those red blocks. We've got a 15x and a plus 20, which is a constant. It's just a number 20, there's no variable attached to it. So they're the two terms we need to look at, and we need to find a factor of those two terms. So each term has two parts to it. It's got a number part and a variable part, and so we need to find any common number factors, but then also any common variable factors. So let's just clear off some of this, and then we can have a go at doing it. Get rid of that. All right. So put that 5 back. So 15x plus 20. So the way that we do this is we first of all start by looking at the numbers, and we say, what is a number that goes into both 15 and 20? So hopefully you can think of the number 5. 5 goes into both 15 and 20. So we write 5 out the front of our answer. Then what we do is we create some brackets, and inside those brackets we write everything just the way it was, 15x plus 20, except we now divide both of those by the number that we stuck out the front of the brackets. So we're going to divide both of these by 5. So that's our first line of working. Then the second line of working, we're going to clean it all up and write our final answer. So on our second line, the 5 will stay at the front because we haven't done anything with that, and the brackets will stay there as well. Now, when you're simplifying algebra fractions or just fractions generally, I guess there's two ways you can think about it. If the numbers fit nicely, then you can remember that this fraction line just means divide. So you could read that as 15 divided by 5 is 3. And then because there was an x up the top there, that x stays in our answer. On the other side, we can read that as 20 divided by 5 is 4. And so we get our final answer, 3x plus 4. Now that way of reading the problem works fine as long as the numbers in the fraction divide nicely like they did then. So in our next example, we've got 4x plus 12. So same thing, we're going to write a factor out the front of our bracket here. So we look at the two numbers, look at the 4, look at the 12. What's a number that goes into 4 and 12? Well, we could put 2 because 2 goes into both of them, but a better answer would be 4. We want the highest number that we can think of that goes into both of them. And so 4 is the highest common factor of those numbers. It's the highest number that fits into both. So 4 goes out the front, we create our brackets, then we just rewrite everything the way it was, but we're going to divide it by 4 because 4 is out the front of our brackets. So there we go. Next line, that 4 stays at the front. We're just going to clean it up a bit. So 4 divided by 4 is 1. The x hangs around. And then 12 divided by 4 is 3. So we end up with 1x plus 3. And in algebra, quite often we don't show the 1. It's just a way to make our writing less cluttered. So we don't need to show that 1. We could just write that as x plus 3, and that means the same as 1x plus 3. Okay, so why don't you have a go at this one? You can pause the video, and then I'll go through the answer with you in a minute. So let's see how you went. First, we're going to start by looking at the numbers, 8 and 16. What's a factor of 8 and 16? Well, there's 2, there's 4, or there's 8. And so 8 is our highest common factor, so we're going to write 8 out the front. If we look at the letters, a bit like the previous examples, we haven't focused on this too much yet because in the ones we've done so far, the second term doesn't actually have a variable. There's nothing there. So we don't need to worry about the letters yet, but we'll get to that in the next problem. So 8 out the front, create our brackets, 8x, we're going to divide that by 8 because that was our common factor, plus 16 over 8. So when we come to clean that up, 8 divided by 8 is 1, that x is still there, 16 divided by 8 is 2, and so we end up with 8 outside of 1x plus 2, which again we can get rid of the 1 and just write that as x plus 2. So hopefully went well with that. Let's have a look at a slightly more challenging one, and it's slightly more challenging because now we have a variable in our second term as well. So we start off the same way. We start by looking at the numbers. So we look at 6 and we look at plus 2, positive 2. What's a common factor of those two numbers? So 2 goes into both of them, so we're going to take a 2 out the front. But with our x's now, what we need to consider is that x squared is really x times x. And in algebra we don't always show the multiplication sign, so we're just going to write that as xx. That's another way of thinking of x squared. So in this one here we've got xx, and in this one here we've just got 1x. So what's common about both of these? Well, we have at least 1x in both of them. There's at least 1x there. So we can take 1x out of both of those terms. Then we do the rest just like we've been doing. So we're going to write 6x squared, and for now I'm just going to write 6x squared like that, 6xx. And we're going to divide that by 2x, because that's what we took out as our common factor. The second term we had was 2x, and we're going to divide that by 2x. So when we come to clean this up, the 2x stays out the front. There's our brackets, and I might change colour. So 6 divided by 2 is 3. And with the x's, one of these x's on the bottom cancels out with one of the x's on the top. And so that leaves us with just one lot of x left over there. In the other term, we have 2x divided by 2x. So 2 divided by 2 is 1. And the x's cancel out, and so we don't have any x's left. So our final answer is 2x outside of 3x plus 1. Now just to clarify, when we're cancelling these x's, we're not actually sending them off into oblivion or out into the ether somewhere. They're not getting deleted or terminated. But what we're saying is this number x, we're dividing it by itself, just like we said 2 divided by 2 is 1. So x, whatever it is, and we can sort of use an example, x could be 10, and so then it would be 10 divided by 10, or x could be 15, it would be 15 divided by 15. Doesn't matter what it is. If we have a number divided by itself, all of these things just equal 1. Something divided by itself is 1. So when we're cancelling the x's, what we're saying is those two x's in that relationship where they're being divided, their value is just 1. And so it's not really adding anything to our problem in terms of giving it extra value. So we can get rid of them basically and make it look less cluttered, and we're not changing what that equation or that expression is worth. So we're able to cancel out those x's because they're just worth 1. Okay, let's have a look at this next example. So in this one here, we've got, with our numbers, if we start there, we've got 4 and negative 6. So what is a common factor of 4 and negative 6? Well, 2 is a common factor, so 2 goes into both of those, so we can write that out the front. Then if we look at the a's, or the variable section of each of these terms, let's just write the a squared again as AA for now. So that means a times a, which would be a squared. And then over here we've got one lot of a. So how many lots of a can we take out of both of those? Well, we can just take out 1, because we could take out 1 from there and there, but then there's no more left over here to take out. So we can't take out anything else. So we're going to take out one lot of a. We'll set up our brackets. We're going to have 4, and again I'll just write 4a squared as 4aa for now. And we're going to divide that by 2a, because that was our common factor, minus 6a over 2a. Alright, next line. So we've got our 2a out the front, Now, when we come to simplify, 4 divided by 2 is 2. One of those a's cancels with the top one. We've just got 1a left. Minus 6 divided by 2 is 3. And those a's cancel out, so there's no a's left. And so we're left with 2a outside of 2a minus 3. Now, there's a way that you can check your answer as well. And you don't always need to write this out as an extra line, but you can do it in your head. If it gets more complicated, of course, just write it out to help yourself do it. But you basically expand the bracket now. So we go this common factor out here times our first term. So 2a times 2a. 2 times 2 is 4. A times a is a squared. And then we go that 2a times our second term. So 2a times negative 3. So 2 times negative 3 is negative 6. And the a tags along for the ride. And so you should end up back at where you started. And that's a little check that you can do to make sure you've factorized it correctly. If you do the expanding and you get a different answer to what you started with, that means you've done something wrong along the way. So go back and check your work. Alright, here's one for you to try by yourself. So have a go at that, pause the video, and I'll go through the answer with you in a minute. Alright, hopefully you went okay. Let's have a look. So when we look at the numbers, we've got 15 and minus 20. So 5 would be a common factor of those. And then when we look at the variables, we've got an x squared and an x. So we can pull out at least one x from both of those. Then we'll do our working out. So we'll write that and divide it by our common factor. Alright. So on the second line, we're going to have our 5x still. And so 15 divided by 5 is 3. One of these x's cancels out with 1 on the top, and that just leaves us with 1x left. 20 divided by 5 is 4, and those x's cancel, so there's no more x's in our second term. So we get 5x outside of 3x minus 4. Okay, last problem. This is probably the most complex one so far. You can see there's multiple variables in each term now. So again, have a go at this one, and I'll go through the answer with you in a minute. Even though it looks more complicated, just follow the same process and see how you go. Alright, let's check and see how you went. So first of all, compare the numbers, 12 and negative 4. So what's a common factor of that? We can take out a 4. Now when we look at the letters here, we might just write this out the long way. So x cubed would be 3 lots of x multiplied together and a y. X squared would be 2 lots of x, and then y squared would be 2 lots of y. So when we're looking to see what we can pull out, there are at least 2 x's in both of them, and there is at least 1 y in both of them. So when we write that out the front as our common factor, we're going to write 4xxy. And in algebra, the way that we would write that rather than 4xxy is just to write 4x squared y. And so x squared means the same as xx. Alright, let's go ahead and finish off the bracket. So we've got 12x cubed y over 4x squared y minus 4x squared y squared over 4x squared y squared. Sorry, 4x squared y, isn't it? I've done too many there. Alright, so let's clean this up now on the next line. So we've got our 4x squared y out the front. And then when we simplify this, 12 divided by 4 is 3. Now we've got x squared down the bottom, so that's really 2 x's are going to knock out 2 x's from the top and just leave us with 1. So we're going to have just 1x left. The y's cancel out, so there's no more y's left in that term. And then as we move to the last term, 4 divided by 4 is 1. X squared cancels with x squared. One of these y's there cancels with 1 on the top, and so that just leaves us with 1y. And so we can just clean up a little bit more by getting rid of the 1 and just writing y. So we have 4x squared y outside of 3x minus y. And so that's a bit of a guide to factorising. Focus on the numbers, find the common factor, then focus on the variables, find which variables are common to both, stick that outside your brackets, and then just divide both of the things that are left in your bracket by your common factor and clean it up.